Hello everyone, I'm Jayadullah Kimon, ID 1706017 from group number 5. This is our final project presentation titled IoT based Smart Agricultural System. My team members are Sheikh Munim Hussain, Shafin Shadman Ahmed, and Ejazul Islam. Here is the outline of our presentation. First, we'll present abstract, then introduction, then design, then implementation, analysis and evaluation, and finally, we'll put some references. The main objective of this project was to design a smart agricultural system using Internet of Things IoT. Real-time data monitoring with surveillance system has been implemented in this project. This project aims at real-life implementation at large scale. As our country is agriculture-prone country, so this project will help prosper our economy. Measuring different data and weather parameters, data have been sent to cloud server and necessary steps have been automated for ease. In summary, DHT11 sonar sensors, rain sensors, etc. and surveillance system with machine learning have been implemented. Automatic water pump system and buzzer system have also been implemented. Here are some pictures of our PCB and our final project. Although Bangladesh's economy depends mostly on agriculture, farmers are still not quite comfortable with digital system and automation. This project will help the farmers with proper information and steps. Because of lack of information, farmers face difficulties to harvest their crops. This project will help farmers decrease their loss. The implementation of this project will ensure maximum harvest and help farmers to get acquainted with IoT. Now, I will say the design methods of our project. Total implementation of our project has 5 segments: data monitoring, application of monitoring, real-time weather monitoring, security system, and finally, leaf image analysis using machine learning and automation. In the data monitoring part, following data related to farming is monitored and uploaded to web server: humidity, DHT11 sensor; soil moisture, temperature, DHT11 sensor; soil temperature, DS18B20 sensor probe; and finally, Node MCU ESP8266 was used to collect data from sensors and send the data to Adafruit IO for visualization. For the application of monitoring part, one application of monitoring the irrigation system is done using the following apparatus. Water pump was used as motor, soil moisture, irrigation system was operated on threshold percentage of soil moisture sensor result. And finally, Node MCU ESP8266 was used for data collection. From now on,
Third segment of the project was to set up an real-time weather monitoring station. In agricultural system, how the weather behaves can have a massive impact on the production. Necessary environmental data like pressure, temperature, or altitude of an area can be helpful to predict possible rainfall or yield of the crop. Along with that, a rain sensor could be a helpful medium for farmers in rural area to take prompt approach. In some cases, rainwater might be collected for irrigation. Also, in some situations, protective measurements can be taken to save the crop from getting rotted. In our project, we have used a BMP180 sensor in which we have provided the altitude of the area as an input. It measures the absolute pressure along with the sea level pressure. A rain sensor was added which can detect rainfall even if it's a small amount. These data were updated in the Blink server. For the fourth segment of our project, we have implemented a security surveillance system. A ESP32 CAM module was used to implement a low-budget surveillance system for the farmer. This can be a great help for them to install the security without costing much. Also, the captured video frame can be used for image processing application. An additional gas sensor MQ135 was added to sense the presence and percentage of the toxic gas in the system. As an application of the ESP32 CAM live feed, leaf image analysis to an automated ML system was implemented. The backend model was a pre-trained VGG16 architecture. Used datasets were plant village and cassava leaf image datasets. The extracted feature was trained on random forest and XGBoost, some of which XGBoost results in higher accuracy. Predicted output was updated on Adafruit IO so that farmer doesn't need to go through all the nitpick of the model itself.
Assalamu alaikum. I am Sheikh Munim Hussain, student ID 1706008. Here we see the basic circuit diagram of our project. Here we will see the board on circuit diagram. It consists of a soil sensor, a DHT sensor which calculates temperature and humidity, and soil temperature sensor which is DS18 B20, and we also drives water pump from this circuit diagram. Next, we will see the circuit diagram of the board 2, which consists of BMP180 sensor, which calculates pressure and altitude. The SR is for O0 sonar sensor, which calculates the water level of the tank. Then we also have a gas sensor, which is MQ138, and a rain sensor, which shows us whether it is raining or not. Both of the circuit diagram, we power up the node MCU with a battery and a 5-volt voltage regulator. Here we see the PCB layout and 3D rendering of our board on and a 3D layout and PCB rendering of board 2. Here we used the double layered PCB. Now we will see the project demonstration, hardware demonstration of our project.
Here we can see the operation of pump along with DHT11 sensor, soil moisture sensor and temperature sensor. Pump is operating on the basis of the value that is given by this soil moisture sensor output. Here we can see the soil moisture sensor along with the soil temperature sensor. Now if we look at the output IO value, we can see moisture is below 50%. So that's why the pump is operating and supplying water to the system. Now in this demonstration, pump is not supplying any water. Obviously, if we look into the output IO value, the moisture sensor is giving the value above 50%. That's why the pump is not supplying any water. Now we look at manual operation of pump using this push button. Here moisture is above 50%. That's why the pump is not supplying any water to the system. Now we press this push button. Pump will start and supply water. Here we can see MQ135 gas sensor. Here we have mounted the sensor, and in order to IO we can see the gas percentage applied by the sensor. Now the gas percentage is under the safe level, that's why the green LED is turned on and no buzzer is running. Now experimentally we will add some gas here by using this light. As the gas is provided, next if we look at the other fruit IO, we can see the gas percentage increases and it is above 50%. LED is turned off. Now in this video we will see how the range sensor actually works. This is the range sensor which is connected with the RT module. The RT module is connected with the PCB through this hole. Now in the other fruit IO we can see it is showing no water is detected. And also the LED is turned on. If we experimentally apply some water here, the sensor should work. As you can see here, it is water is detected, LED is off. And also, if we look into the RT module next, it is showing that the water is detected through its green LED. Next, we look at BMP180 sensor, which is placed here with our PCB board 1. BMP180 sensor can provide information about the altitude value of the current location along with the absolute pressure and sea level pressure, which is demonstrated. Now the selected XGBoost classifier works pretty well on single leaf image, but multiple leaves result in confusion. Later, cassava leaf image dataset was used to train the model on multiple healthy leaves. And as you can see, the improved model has managed to detect healthy leaves in both single leaf and multiple leaf case. But a labeled dataset which contains image of multiple leaves with disease couldn't be found. As a result, this results in an inability of the model to perform on multiple leaves. Further improvement is possible in this area. As you can see, the model can correctly predict early blight disease in a single leaf, but the prediction was wrong for multiple leaf as it predicted as late. We have a demonstration video of the automated ML model with ESP32. Now we look at the mounting of ESP32 cam module. Here we have placed it to see the images of the plant through its camera module, and it is powered through this power bank. Now we'll see an application of ESP32 camera module live stream. Here you can see the live stream on the left side. Here we run the model. Now the model is predicting on the basis of the leaf image input. As the leaf image condition is healthy here, it is predicting healthy input, healthy output here. Now we look at an application of ESP32 camera live stream. If we run this ML model here, it will predict on the basis of the image input that is given by the ESP32 cam module. As the image is healthy here, the output is given by the model is healthy. Now, if we look at more focused view of the images, then we can see still it is showing healthy, but if it is focused on this particular leaf with yellow spot, late blight output is given.
Hello everyone, I am Shafi Satman Ahmed and I am presenting from this part of our project presentation. So while analyzing and evaluating our project, we considered some crucial points, these being novelty, project management and cost analysis, practical consideration of the design, assessment of the impact of the project and evaluation of the sustainability. So One of the novelties of our project is that different IoT sensors have been implemented together to form a smart agricultural unit where the output from all the sensors have been sent to the cloud servers with the help of Internet of Things. Another novelty is that the pumps and surveillance cameras that have been used in this project can be implemented by just using the sensors. In addition to these, a machine learning model has been implemented which can be used to detect healthy and unhealthy plants with the help of surveillance cameras. Here we come to the bill of materials. The bill contains equipments like DHT11 sensor, BMP180 sensor, HCSR04 sensor, rain sensor, ESP8266 boards, ESP32 camera module, PCB, plants, and an aquarium. So the number of units bought, the unit price, and the total price have all been shown in a table. While coming to the practical considerations of our project design, some points have been considered: the points of public health and safety, environment and culture, and societal needs. In terms of public health and safety, it can be assured that the equipment used in this experiment are safe. Mm, Although one power source is used to some power up some sensors, sometimes the impact of this power source on the whole project is minimal. And speaking of environment, this project itself monitors the changes in environment and informs this to the farmers. So there should be no possibility of any harm to the environment from this project. And if the farmers are accepting of this project like this can bring considerable changes in Bangladesh's agricultural systems, and such projects can make farmers' lives easier a lot. While assessing the impact of the project, some issues were considered, these being societal, health and safety, legal, and cultural. As I said earlier, if farmers are readily accepting of such a project and if they are able to ease their farming, there is a strong possibility of an overall social development. In terms of safety, the project and its equipments can be considered safe, but even after that, some safety measures can be taken for better precautions. In terms of legal issues, no illegal activity was performed while conducting this project. And from a cultural standpoint, some farmers may oppose this project because they may think that this project will collide with the traditional farming lifestyle. But if considered from a long-term perspective, such a project will be beneficial to the farmers. While evaluating the sustainability, we also evaluated the impact of the design in societal and environmental context. We can say that our project is quite sustainable. Only the power source should be recharged after some time for a small period of time. If we don't want to recharge our batteries like this, an alternative could be solar cells. Mm. And in terms of impact of design in the societal context, it can be said that although many farmers are not familiar with such digitizations and modern technological aspects, this project has been made for so that the farmers can easily understand the application, and by such projects people can get interested about technology. From the environmental context, there is one caveat. The caveat is lithium ion batteries. These may be thrown after the usage, which is a possible cause of environmental hazards. So it should be checked that the renewable energy sources should be considered, or if lithium ion batteries are disposed, they should be disposed of properly. A project comprises of both individual efforts and team efforts. So when we reflect on individual works and team works, we consider some points, these being individual contribution of each member, mode of teamwork, diversity statement, and a logbook of project implementation. As I said earlier, the project requires both individual and team efforts. So from here we can have an idea of who contributed in what factors individually. The Sheikh Munim Hussain worked on gas sensors, rain sensors, and the port PCBs. Muhammad Jahidul Haq Imon worked on surveillance system and Adafruit IO interface. Shafin Sadman has worked on irrigation system and the sonar sensor, and Ejajul Islam has worked on BMP 180 sensor machine learning model training. So while we perform this project, we thought a bit of diversity. So it can be said that our team is quite diverse. For the four members of our project come from four places. Munim is from Satkira, Imon from Brahmanbaria, Shafin from Kushtia, and Ejazul from Dhaka. And two of our members are hall residents, while two are attached. Each of us has our own interests and hobbies. And while performing the project after class time, we usually work together, by gathering in any hall room and central library. These have been beneficial for our work, and after buying different equipment, ordering them, and working, all of them have been done together.
Here is a logbook of our project. This shows different dates and the milestones we have achieved individual and with a team. Here are some references that we used for our project. These references used us heavily to get success in the project. Thank you everyone for listening to us till now.